All right, good day, everyone. What we're going to be talking about today is the co-function identity, okay? And really, one of the key things I want you to understand within this lesson is that the main topic that we're going to talk about and bring back is always going to be our reference angles. And how, if I have an angle in the first quadrant, how can I relate that to the other three quadrants? On top of that, what are the coordinates of each of those quadrants? What are x and y? And how does that relate back to sine and cosine? Okay. Using all this information, we can actually create a co-function identity, okay, to help simplify, once again, trig functions. So let's go ahead and get into it. The first piece of information that you need to understand is this idea of a reference angle and how it relates to sine and cosine. Okay, we've been talking about reference angles quite a bit. We've had a couple different discussions, a couple different lessons, as well as a pretty intensive unit in which we needed to kind of understand this idea of a reference angle. Okay, but in this unit, we're specifically going to be talking about, once the pen starts working, there it goes. We're going to be talking about specifically how can I relate a cosine or sine function to these reference angles. So the first context you have to understand is kind of this main idea. A reference angle is always referring back to an angle within that first quadrant, kind of like how we talked about earlier in the year. So this original angle has to be in between 0 and 90 degrees, or 0 and pi over 2. Okay, that's the original reference angle. On top of that, you need to kind of note that in this region, you would always have a positive x and a positive y. Well, if you notice, one of the things they relate back to that is that if both of those are positive, then both sine and cosine also have to be positive in that region, okay? Versus if you were to flip this, let's just say you were to go into this region, which is 180 minus that reference angle. Now we want to talk about how does that affect your graph? Well, this would be your line now at this point. Your reference angle would be in here. And then in that region, since you would have a negative x and a positive y in reference to sine and cosine, that would mean that in this region here, you would have a negative cosine, because that is your x value, and a positive sine value. Sorry about that. Sometimes smart notes kind of go off there. So we'd have a negative cosine and a positive sine function. Once again, the reason is because it always relates back to the coordinate. So where you're at in respective of the coordinate plane is going to be a huge difference within this problem. And that's really what we're going to look at today. How can I look at an identity and actually assume where that value is going to be, or how is that going to affect sine and cosine? So if I look at this next problem here, let's kind of look at what they're doing. They're giving us the same picture, but they're asking us in particular, how would it change if theta was negative? So if you notice down here, they're asking us, what would a negative theta do to my sine and my cosine? Well, once again, we want to think about the reference angle. If this is a positive reference angle, well, a negative reference angle is just going to flip it and be down here, okay? This is a negative theta, that angle there, okay? So now when I think about sine and cosine, we have to think about where is, or what's happening in that coordinate, or excuse me, what's happening to our coordinates within that region, okay? And when I look at that, I'm thinking, okay, in quadrant 4, you have a positive x because it's to the right, but a negative y. Well, in terms of how that's affecting our sine and our cosine, a positive x means I should have a positive cosine. A negative y means I should have a negative sine, okay? So notice how this is affecting my values based off of those coordinates, okay? And because of that, it's creating a different sine or cosine function. This is where the idea of cofunctions come in. So now, if I have sine of negative theta, technically that's an identity of negative sine of theta. Versus if I have cosine of negative theta, technically based off the region we're in, that's just the same as cosine of theta. Or really, there's not a lot of change to it. It's still a positive cosine value, okay? Now, this is kind of the basic version of it, but each Cofunction is a relation back to its original reference angle, okay? And how we can actually use that to establish different values with, or excuse me, around a graph, okay? So if we continue on and look at some of these other reference angles, let's just talk about how this can kind of always work. In this particular problem, number 2, we're going to be talking about how does it change if I have 180 plus and 180 minus, okay? Once again, the thing you really need to understand is where am I located on the graph if I add 180, excuse me, if I add to 180 or if I subtract from 180 with our reference angle, okay? And the first thing you have to understand is where am I located on the graph? Well, if our reference angle is always in between this portion here, okay? If that's where our reference angle is always located, we want to understand how it's going to affect it when I do these two calculations. The first one being, if I take 180 minus a reference angle, if I take 180 minus a reference angle, we should always end up in quadrant 2, okay? Because this value here is always between 0 and 90 degrees, and what we're doing is we're subtracting 180 from it. So if I just say that this coordinate is 60 degrees, if I plugged into that equation, I would be at 120 degrees, which is over here, correct? So you see how I can always use those reference angles to my advantage to know positioning. Same thing if I continue that thought process. If I take 180 and add my reference angle to it, that same idea would be put into place. If I had a 60-degree angle and I plugged it into that equation, well, 60 plus 180 would be down here at 240 degrees, leaving me in the third quadrant. So you see how those values or those equations are actually telling me a reference point within the actual coordinate planes. Well, with that being said, let's actually look at how this would work. If I look at sine of 180 plus theta, okay? Once again, I want to understand what's happening within that quadrant. So if I do sine of 180 plus theta, like letter A says here, technically that's this coordinate here or this theta. And if I add 180 degrees to it, I'm down here in the third quadrant, okay? In that quadrant, we're basically trying to think of what's our coordinates doing. Well, in this quadrant, you have a negative x and a negative y, which means for letter A, sine if I have sine of 180 plus theta, well, because it shifted me from my original sign down to here, that's the same as negative sine of that reference angle, okay? The identity of this is the same as this value. Once again, it's all about positioning. If you are positive up here, because that's a positive y coordinate, when I add 180 to it and come down to this position, I become negative, because now I have a negative y coordinate, okay? Let's continue to look at this as a whole. Let's continue to look at a couple more. If I look at letter E, okay, let me change colors here. A little too much blue on the screen. If I look at letter E, E is cosine of 180 minus theta. So now that idea is if cosine's positive here, and here's my original reference angle, if I do the reference angle minus theta, I'm in quadrant 2. So now this is my 180 minus theta. In that region, I'm thinking, okay, you have a negative x and a positive y, because I'm going left and up to actually plot that coordinate. Well, because of that, when I look at this particular value, cosine of 180 minus theta has to be the same as negative cosine of theta, simply because if I go to this quadrant or this region of the actual coordinate plane, you have a negative x, meaning that this cosine 180 minus theta has to be the same as negative cosine of theta, okay? And that's kind of the process we take with all these. The last two cofunctions that we usually see, at least in the degrees portion, are going to be when we have a 360 plus or minus values, okay? Now, one of these should be fairly straightforward, okay, especially with the 360 plus. If I have 360 degrees plus a reference angle, understand really what's that going to do, okay? If I start here as my original reference angle and you add 360 degrees to it, you're going all the way around the unit circle until you're back at that same location. So you see how really there was no change? I added 360 degrees, but I'm back where I started because I did one full revolution. So if I add 360 degrees at theta, I'm back in quadrant 1, and we can use that to really think about what's our values. So for example, if I look at letter A, if I do sine of 360 plus theta, well, once again, there's really no change in my problem. I started with a positive sign. If I go back to that same location, I'm going to end with a positive sine function. Okay? Versus the other one you could see would be a 360 minus theta, which once again, let's try to think about where that would be. If this was a reference angle here, if I would take 360 and subtract that value, we want to try to think about what quadrant would I be in. Well, once again, we can kind of prove this just by plotting a specific degree in there. If this was a 60-degree angle, a value that was in that first quadrant, if I were to plug it into 360 minus theta, that would bring me to an angle down to here, which is a 300-degree angle. Okay? You see how just by doing 360 minus the original reference angle, I'm traveling down to that fourth quadrant. Okay? So when I use this expression, what I'm saying is I'm in the fourth quadrant of this unit circle or this coordinate plane. From there, I can really build off of that. For example, if I look at letter D, now if I look at sine of 360 minus theta, now I'm no longer in the first quadrant. I'm down here, which is a positive x, negative y. And then we just look what it relates to. Sine relates to the negative y value. So 360 minus theta has to be the same as negative sine of theta. Okay? And so understand, the big thing that cofunctions really relate to is positioning within a coordinate plane. They go back to our reference angles, in which we talked about how we can go through and really plant a reference angle in any quadrant. What the cofunction identities do is now basically expand on that and say, okay, what is happening when I travel to that quadrant? Really, all this is asking is if I travel to quadrant 4, what happens to sine? Well, the identity is sine is negative. Versus this one, if I travel to the first quadrant, or if I go all the way around the circle once, what happens to my sine function? Well, its identity is sine stays positive. Okay? Now, we'll go more in depth in class and talk about some other problems we could use this in. However, that was kind of the main idea of the lesson. Okay? Answer any questions in the video besides that. Have a great day, and I'll see you tomorrow in class.